So here's a demo video of using PyKMC with the various input parameters as well as checking out some of the output. So first thing I'm going to make sure is I'm in the virtual environment that I set up during installation. And now I'm going to go into some of the examples. I'm going to pick the nickel SIA example. Checking what's in here, we have initial configuration file in XYZ format, the input script, and the potential file with EAM format. So checking out the input file, we have some parameters being defined here, but what I will change is the part N plugin reference location to make it accurate to my own system. Save that. To begin the simulation, I will run python -m PyKMC -in input.in. And after it starts, you can see that it prints out all of the simulation parameters, even ones that weren't explicitly defined in the input script, and otherwise it just sets them all to their default values or nothing. We can see we set n steps to 10, so we'll do 10 KMC steps. We can see that the temperature was set to 300 Kelvin. We have our minimization parameters, our potential file here, all of our part N search parameters, and our reference to the library file. Down here, initialization's done with the initial configuration, initializing the lamps engine, minimizing the system, new neighbor lists, finding atomic environments, initializing a reference table. And we can see here at the start of the step, the simulation begins searching for any new atomic environments. In this case, there were 3 environments found, so 10 searches per environment is conducted for a total of 30 reference events. Just as a side note, all of these parameters can be found on either the PyKMC repository documentation under docs and parameters details, and this is just in the develop branch. And for the part N plugin, there's the wiki page, which has all the input parameters listed here. So after all of the reference events have been searched, any relevant events are placed in the reference table, and any remaining significant events are put into refinement. And at the end of the step, the system is minimized and the simulation moves on to the next step. And in this case, no more atomic environments were found, so no more reference events needed to be checked, and the step simply consists of the refinement of the same 8 events that were refined in the previous step. After the remaining steps, which was pretty much just refining the same 8 events, wait until this step is finished. Refining is done, final minimizing, and that's it. So, checking the output of the simulation, we have some extra files generated here. First, we have this artn.out. This is a catalog of the search algorithm, the steps that it takes, and all of these column parameters can be checked on the Part N wiki page online. The initial config was here already, input script. This lamps log file simply states the commands being run. We can see minimization, some citation information, and just common run info of the operations being run using the lamps engine. Next is PyKMC.info. This is a catalog of a more detailed list of PyKMC parameters per step. PyKMC.log, which is essentially just a copy of what's printed to the terminal window when you run the simulation, minus the progress bars. We have PyKMC.out, which is also an important output file. We can see these are the parameters that are listed in the columns here. Importantly, we have the time difference per step, and we have the total time, cumulative time for the full simulation. It can be noted that the cumulative time at the last step is much less than even a femtosecond, which is a good indication that either a different system should be used or the temperature should be reduced. And we have reference table, we have visited environments, and these are both pickle files. They're not in the human readable format. These are binary serialized data formats used by Python. And here this trajectory XYZ file is most useful for viewing the simulation in a visualization tool such as Avito. So I'm just doing here, opening the file with Avito. And we can see that we can jump through each step of the search process. And that's a simple example with PyKMC.